So last time we talked about section 8.3, which is about the side, 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 and side angle side triangle theorems. So today we're going to talk about proportionality theorems. We first have our theorem 8.6, which is the triangle proportionality theorem, which states if we have two parallel lines, TU and QS, then we can say we have a proportionality of RT over TQ is proportional to RU over US. We also have theorem 8.7, which states the opposite, or the converse, which is the converse of the triangle proportionality theorem, which states if we have a proportionality between the two sides of the triangle, so RT over TQ is proportional to RU over US, then we can say that the lines TU and QS are parallel to one another. Now let's go through an example. This example is a lot like our first theorem, theorem 8.6. So in the diagram, we're given that WZ is parallel to XY, which we can see noted by these markings, okay? And then we know that WX equals 12, so that's this line. We have VZ equals 10, and we have ZY equals 8. We're trying to find the length of VW, the only side that is not labeled. To solve for VW, since we know we have the two parallel lines, we know we have a proportionality between those two sides of the triangle. So our proportionality should look like something like this, where VW over WX is proportional to the side with VZ is over ZY. Now, if we plug in our known values, we get VW, which is what we're trying to solve for, over 12, which is what WX is. We know VZ is 10 and ZY is 8. So to solve for VW, you must cross multiply, so the 12 and the 10, multiply those together and divide by the remainder, which is 8, and you should get 15. So we get VW equals 15.